Imagine this: a vast, silent expanse of space, where stars whisper secrets across billions of years. Suddenly, on a crisp July day in 2025, something extraordinary pierces our solar system's quiet routine. From the depths of interstellar void, an uninvited guest hurtles toward us at 137,000 miles per hour, faster than any human craft could dream. This is 3I/ATLAS, the third confirmed interstellar object to grace our celestial neighborhood, discovered by the ATLAS telescope in Chile on July 1st, 2025. Not just a rock or ice chunk, but a comet born under an alien sun, ejected eons ago, now weaving through our worlds like a nomadic storyteller with tales from afar. Picture the excitement rippling through observatories as Precovery images from June 14th, 2025, confirmed its hyperbolic path, unbound by our sun's gravity, destined to visit and vanish forever. At first, a faint blur, magnitude 18, barely a whisper in the night sky. But as it barreled inward, past Jupiter's orbit, something stirred. Dust and gas wafted from its icy core, forming a hazy coma and subtle tail, painting it as a true comet, alive with activity. Scientists held their breath. This wasn't Oumuamua's enigmatic tumble or Borisov's carbon-rich glow. This was something new, a treasure chest of extrasolar secrets, estimated at up to 5.6 kilometers across. Larger than many comets we've known, yet shrouded in mystery. Feel the pulse of discovery, that raw human thrill when the unknown knocks. If you're feeling that spark, smash that like button and subscribe for more cosmic adventures. Share this with a friend who stared at the stars and wondered, are we alone? Let's dive deeper together. As 3I/ATLAS raced closer, crossing Mars's path by October 3rd, 2025, its behavior shifted in ways no one predicted. Once a steady glow, its brightness surged unexpectedly, climbing from magnitude 17 in July to around 12 by early October. Brighter than forecasts, as if awakening from a long slumber. 4 independent observatories flagged this rapid intensification, a coherent spike across visible, ultraviolet, and infrared wavelengths. Was it a natural flare-up, or a hint of something more profound? NASA's fleet, Hubble, JWST, Swift, and Mars orbiters, snapped to attention, treating this not as routine passage, but a live cosmic drama unfolding in real time. Transitioning from the outer fringes, where temperatures plunged to unforgiving cold, 3I/ATLAS began its transformation. Infrared eyes from the James Webb Space Telescope, peering on August 6, 2025, revealed a coma dominated by carbon dioxide, a staggering 129 kilograms per second, venting into space, with water at 6.6 kilograms per second and carbon monoxide at 14 kilograms per second. The CO 2 to H2O ratio, a whopping 8 to 1, far higher than most solar comets, suggesting this wanderer formed in a frigid, carbon-rich cradle beyond its star's snowline. Water ice, fine and amorphous, sublimated thousands of kilometers from the nucleus, driven not by solar heat alone, but by explosive release of trapped volatiles. Here's where the heart races. At over 3 times Earth's distance from the Sun, more than 4 astronomical units out, the comet spewed hydroxyl, the ultraviolet fingerprint of water vapor, at 40 kilograms per second. Like a cosmic fire hydrant unleashed, this early outgassing defied expectations. Typical comets wait until closer in, where heat cracks their icy shells. Yet 3I/ATLAS, perhaps scarred by billions of years in radiation-blasted interstellar space, fragmented small ice shards that vaporized prematurely, swelling its coma to twice Earth's diameter by July. Ground telescopes captured the shift, a reddish hue from large dust grains laced with organic tholins, turning the coma into a glowing, ethereal shroud. Emotional layers deepen here. Think of this comet as a time-weary traveler, carrying scars of galactic exile. For eons, it drifted in darkness, bombarded by cosmic rays, its surface altered into a protective crust. Now, under our sun's gentle warmth, it's shedding layers, revealing inner vulnerabilities. That surge in brightness, not a fade into obscurity, but a brilliant rebirth. Magnitude climbing faster than models predicted, reaching peaks that demand recalibration. Astronomers felt awe and urgency. This wasn't passive observation, it was witnessing evolution. If this vivid rebirth captivates you, drop a comment below. What do you think triggered this surge? Like and share to spread the wonder. Let's ignite conversations across the globe. As brightness intensified, NASA's command centers buzzed. By mid-October 2025, with perihelion looming on October 29th at 1.36 astronomical units, the agency elevated monitoring to alert status. Hubble's sharp gaze from July 21st images pinned the nucleus size between 0.32 and 5.6 kilometers, while Swift's ultraviolet scans confirmed the OH flood. Mars orbiters, ExoMars TGO, and Mars Express snagged close-ups during the October 3rd flyby, revealing an asymmetric cyanide coma stretching 180,000 kilometers, with hydrogen cyanide production doubling to 4.5 times 10 to the 25th molecules per second. Ground arrays joined the chorus. The Very Large Telescope detected cyanide at 17.6 grams per second and nickel vapor at 4.6 grams per second, hinting at decomposing organics. SphereX spotted strong water ice absorption and an extended CO2 envelope. Even amateur astronomers contributed, their backyard scopes capturing the evolving tail, initially faint and broad, now a 100,000-kilometer dust streamer, fan-shaped from sunward jets. The coherence of this brightening across bands, no mere atmospheric glitch, but a genuine physical metamorphosis, sparked interagency synergy. Jet Propulsion Lab simulated dust dynamics. Goddard parsed light curves, modeling the surge as particle expansion or volatile bursts. This global vigilance evokes profound unity. From Chile's highlands to Mars's red plains, humanity's eyes unite on one fleeting visitor. It's a reminder of shared curiosity, transcending borders as ESA and JAXA lend their scopes. The stakes? High. As the largest interstellar comet observed, 3I/ATLAS offers glimpses into distant stellar nurseries, metal-poor, volatile-rich worlds unlike our own. Pause and reflect. In a divided world, isn't this collective gaze inspiring? Hit like, subscribe, and comment your thoughts on this interstellar unity. Delving into explanations, scientists ponder natural triggers for this brightening. 1. Volatile outgassing ramping up. As solar heat penetrates the crust, CO2 and CO explode outward, ejecting dust at 6 kilograms per second for fine particles and 60 kilograms per second for larger ones, scattering sunlight more efficiently. This could explain the rapid magnitude climb from 16 in late July to 12 by October, with a projected peak of 11.5, not naked eye, but binocular brilliant. Another scenario, structural shifts. Internal fractures, built from eons of cosmic ray bombardment, release buried ices in bursts, creating fan-shaped dust plumes and asymmetric coma. Polarization data shows high negative values at small phase angles, suggesting a mix of icy and dark grains clumping electrostatically, altering light scatter for a redder, brighter hue. A third, phase transitions in exotic ices. The high CO2 dominance, unmatched except in rare solar comets like C/2016 R2, might cause abrupt sublimation, especially with detected OCS and depleted carbon chains. No iron, oxygen, or dicarbon. This points to a radiation-rich formation environment, lacking protective envelopes, leading to self-alteration upon solar entry. The thrill lies in the speed, brightness oscillating with a 16-hour rotation period, decreasing variations as coma obscures the nucleus. If this surge signals evolving chemistry, tholins forming soot-like coats, yet boosting reflectivity temporarily, it redefines comet aging. Interstellar wanderers, unlike Oort cloud kin, might brighten unpredictably, revealing hidden reservoirs. Emotionally, it's humbling, a speck of alien matter, teaching resilience amid cosmic harshness. Share if you felt small under the stars. Let's connect through this universal story. Amid data deluge, a bolder theory emerges. Harvard's Avi Loeb, in August 2025 writings, posits a 30 to 40% chance 3I/ATLAS isn't natural. Why? Initial lack of a classic tail, trajectory hugging the ecliptic plane, inclined 5 degrees, unusual size, and forward glow possibly from ablating a thin dirt layer. On his lobe scale, it's a 4. Worthy of vigilance, like crossing a busy street. Lobe dreams big. If technological, it could be a probe or relic, offering leaps in knowledge. Imagine reverse engineering advanced materials, inspiring interstellar voyages. NASA counters. Cometary signatures abound. Emissions match natural processes. No artificial signals or maneuvers detected. It's a comet, they affirm, but the debate fuels passion. This tension stirs hope mingled with caution. What if we're not alone? The galaxy interconnected, exchanging not just matter, but perhaps messages. Comment below, alien tech or natural wonder? Like and share to fuel discussion. Implications ripple outward. If 3I/ATLAS's surge reveals unique evolutionary paths, rapid brightening from interstellar aging, it reshapes comparative planetology. Comets as galactic couriers, trading chemistry between stars, hinting at life's universality. High CO2, water spewing far out, precursors to organics, seeding distant worlds. Observationally, it demands nimbleness. Early detection, crucial, as brightness spikes unpredictably. Future surveys like Rubin Observatory might uncover dozens, broadening searches for faint, fast-evolving intruders. NASA's Comet Interceptor, eyeing the late 2020s, will draw lessons, prioritizing volatile targets, designing for dynamic behaviors. Globally relatable. This comet bridges urban stargazers to remote villagers, all under one sky. It evokes wonder, fragility, a reminder that in cosmic time, we're brief sparks. Yet in brevity, opportunity blooms. Like, subscribe, and comment. How does 3I/ATLAS change your view of the universe? As October 29th, 2025 nears, tension builds. At perihelion, 1.36 astronomical units from the Sun, heat intensifies. Will the surge peak or fragmentation ensue? Models predict no disintegration, unlike sun grazers, but watch for outbursts. JWST's December scans will probe post-perihelion coma. Hubble's UV for sulfur ratios. Imagine, a comet, forged in alien fires, tested by ours. Dust tail elongating. Cyanide coma swirling asymmetrically. Emotional peak. Witnessing change, like a butterfly emerging, beautiful yet ephemeral. Share predictions and comments. Let's speculate together. Beyond science, 3I/ATLAS touches souls. Amateur scopes track its path. Families gaze upward, united in awe. It's poetic, an emissary whispering of distant nurseries. It's brightening a beacon of connection. Philosophically, impermanence reigns. This visitor leaves by 2026, data its legacy. Yet it inspires. Shift from earthly strife to cosmic pursuit. Like and share. Spread this global tale. The surge of 3I/ATLAS is no fleeting spectacle. It's a clarion call reshaping how we hunt for cosmic wanderers. Data pouring in from October 2025 will fuel decades of inquiry, a legacy etched in spectra and light curves. Spectroscopists will pore over molecular lines, chasing rare signatures like OCS or faint cyanide radicals, potentially uncovering exotic ices never cataloged in our solar system. These could hint at chemical pathways unique to metal-poor, carbon-rich stellar nurseries, environments where volatile ices condense far beyond a star's warmth, preserving primordial matter from the galaxy's infancy. Imagine the implications. A comet revealing not just its own history, but the chemical diversity of unseen worlds, perhaps even the precursors to life's building blocks. Dynamicists, meanwhile, are recalibrating models of interstellar trajectories. 3I/ATLAS's path, skimming the ecliptic with a velocity of 61 kilometers per second at perihelion, suggests ejection from a chaotic system, perhaps a giant planet's migration or a stellar flyby disrupted its orbit billions of years ago. By reverse engineering its hyperbolic arc, scientists can simulate the gravitational dance that flung it into our realm. These models could pinpoint the likelihood of similar visitors, estimating that our galaxy might host trillions of such objects, a silent armada exchanging matter between stars. The brightening event, oscillating with a 16-hour rotation, hints at internal stresses or asymmetric venting, offering clues to the comet's porosity and resilience. Such data refines our understanding of how comets survive eons of cosmic radiation, only to erupt in activity when kissed by a new star's light. Chemists are equally enthralled, diving into simulations of how interstellar ices react to solar heating. The high CO2 dominance, 129 kilograms per second versus 6.6 kilograms per second, of water, suggests a surface layered with radiation-altered crusts, possibly tholins, or complex hydrocarbons. As sunlight penetrates, these layers may decompose, releasing bursts of gas that sculpt the coma's fan-shaped tail. This could explain the surge to magnitude 12, a temporary flare as fresh ices sublimate before darker residues recoat the surface. Such cycles, if confirmed, would reveal how interstellar comets self-regulate, balancing outgassing with thermal inertia. This knowledge could inspire earthly applications. Think cryogenic systems mimicking nature's insulation, or spacecraft coatings designed to withstand cosmic rays, drawn from 3 I/ATLAS's natural armor. The broader astrophysical impact is staggering. Current estimates, based on detections of bright visitors like Oumuamua and Borisov, suggest one interstellar object passes through our solar system annually. But 3 I/ATLAS's rapid brightening implies many arrive dim, evading detection. If most interstellar comets flare briefly before fading, we're undercounting the galactic population by orders of magnitude. The Rubin Observatory, set to begin full operations in 2026, could detect dozens yearly with its deep, wide-field surveys. Machine learning algorithms, trained on 3 I/ATLAS's light curves, will flag anomalies in real time, distinguishing hyperbolic intruders from local debris. This could reveal a galaxy teeming with wanderers, each a courier of chemistry, potentially carrying organic seeds that link star systems in a cosmic web of exchange. For future missions, 3 I/ATLAS is a blueprint. NASA's Comet Interceptor, slated for 2029, aims to park a spacecraft in a holding orbit, ready to chase the next interstellar visitor. Lessons from this comet's volatility: brightness spiking unpredictably, coma asymmetry from uneven jets, will shape instrument design. Cameras must capture rapid changes. Spectrometers prioritize volatile lines like CO2 and CN, and navigation systems adapt to erratic trajectories. The mission might deploy nanosatellites to image the nucleus up close, revealing fractures or vents invisible from Earth. Such data could confirm if 3 I/ATLAS's surge stems from internal cavities collapsing or exotic ices sublimating, guiding how we intercept future transients before they slip back into the void. This legacy extends beyond science to humanity's ethos. 3 I/ATLAS reminds us that the universe is dynamic, its treasures fleeting. Its surge, peaking near perihelion, demands we act swiftly. Every hour of observation counts. Future surveys will need global coordination, with telescopes like ESO's Extremely Large Telescope and China's Fast Radio Array joining NASA's fleet. Amateur astronomers, too, play a role. They're data-feeding citizen science platforms to track faint outliers. This comet teaches us to look not just for the bright, but the ephemeral, broadening our gaze to catch the galaxy's hidden travelers. Emotionally, it's a call to dream bigger. Picture a future where we not only observe, but touch these visitors, landing probes to sample their alien ices. The data could rewrite textbooks, revealing how planetary systems form, evolve, and share material. If 3 I/ATLAS carries prebiotic molecules, as its organic-rich coma suggests, it might affirm that life's ingredients are universal, scattered by comets across the cosmos. This isn't just science, it's a bridge to existential questions, connecting us to the stars. What future discovery excites you most? A probe landing on an interstellar comet, or decoding its chemical past? Drop your thoughts in the comments, like, and share to inspire others to join this cosmic quest. As 3I/ATLAS blazes through our skies, its surge to magnitude 11.5 by late October 2025 is more than a celestial event. It's a global invitation to wonder. From Chile's Atlas Discovery to the synchronized watch of NASA, ESA, JAXA, and backyard stargazers, we've united in a shared pursuit. This comet, born under an alien sun, has become a mirror reflecting our curiosity, resilience, and yearning for connection. Its brightening, a cosmic flare, speaks to the fragility and vibrancy of the universe, a reminder that even in vast darkness, light emerges, however briefly. Reflect on this. For billions of years, 3I/ATLAS drifted alone, a silent witness to galactic history. Now, under our gaze, it transforms, shedding dust and gas in a spectacle visible from Earth, Mars, and beyond. Its coma, stretching 180,000 kilometers, glows with cyanide and CO2, a chemical fingerprint alien yet familiar. This isn't just data, it's poetry, a narrative of endurance and change. As it nears perihelion on October 29, 2025, and begins its exit by mid-2026, we're not just observers, but participants in its story, capturing a fleeting chapter before it returns to the interstellar abyss. The human connection runs deep. Across continents, from urban rooftops to rural fields, millions turn their eyes skyward. Amateur astronomers, wielding modest telescopes, share grainy images online, sparking discussions in forums from Tokyo to Tucson. Families pause dinner to point at the stars. Children asking, where did it come from? Scientists, too, feel the weight. Working late at Goddard, JPL, or ESO, they parse spectra, debate models, and chase epiphanies. This shared awe transcends borders, languages, and divides, uniting us in a moment of cosmic intimacy. For a brief window, we're not just Earthlings, but galactic citizens, linked to a visitor from a star we'll never see. Philosophically, 3I/ATLAS challenges us to embrace impermanence. Its light, peaking now, will dim as it recedes, leaving only data and memories. Yet in that transience lies profound beauty. Like a shooting star, its brevity amplifies its impact, urging us to seize the moment. This comet, with its volatile heart and radiant coma, mirrors our own fleeting existence, bright, dynamic, and destined to fade. Yet it inspires action, to observe, to learn, to connect. It's a call to shift from earthly conflicts to cosmic aspirations, to see ourselves as part of a larger tapestry woven by stardust and time. The scientific legacy is just beginning. As 3I/ATLAS exits, its data will fuel decades of study. Journals will dissect its light curves. Conferences debate its origins. Did a stellar encounter eject it, or a planet's gravitational slingshot? The high CO2, the hydroxyl flood at 4 AU, the nickel and cyanide emissions, all point to a formation environment unlike our Oort cloud. This could redefine how we model planetary system evolution, suggesting that carbon-rich comets are common in young, metal-poor systems. If so, the galaxy might be a chemical highway, with comets like 3I/ATLAS ferrying life's ingredients across vast distances. For the public, this comet is a gateway to science. Its story, splashed across media, ignites curiosity in classrooms and homes. Teachers craft lessons on interstellar chemistry, students plot its trajectory, and citizen scientists contribute data to global databases. This isn't just NASA's mission, it's humanity's. The surge, captured by 4 telescopes in unison, proves our collective power to unravel the cosmos. It's a testament to what we achieve when we look up together, pooling knowledge from professional observatories to backyard scopes. As we close this chapter, the story of 3I/ATLAS continues. Its light may fade, but its lessons endure. It challenges us to refine our tools, faster alerts, smarter algorithms, global networks, to catch the next visitor. It urges us to dream of missions that don't just observe, but touch, sampling alien ices to unlock their secrets. Most of all, it reminds us of our place in the universe, small, yet capable of profound discovery. Every photon we capture, every spectrum we analyze, is a step toward understanding not just three I/A TLAS, but ourselves. Thank you for joining this cosmic journey. If this tale of a wandering comet stirred your soul, hit that like button, subscribe, and share with friends. Drop a comment. What's your takeaway from 3I/A TLAS? Do you see it as a scientific marvel, a philosophical muse, or both? Let's keep the conversation alive, fueling wonder across the globe. The universe awaits our next discovery. Together, we'll be ready.